Hi everyone, we're going to start tonight's video with a quick review of the two terms that seem to give us a little bit of problem in today's class. The first is scarcity. As a quick reminder, scarcity refers to the fact that, as we said, we live in a world of limited resources. So because we can't have everything we want, we have to make choices. And that really is the basics or essence of economics. Second term is opportunity cost. Opportunity cost, simply stated, refers to something you give up to get something else. So I have a couple of examples here. You spend time this evening watching my video. The opportunity cost, or here I put OC for shorthand, the opportunity cost of watching the video is the value or benefit of anything else you could have done with this time. You could have slept, you could have watched a movie, you could have studied somebody else's class. Second example, I used some of this month's paycheck to pay my mortgage, and did that instead of buying a vacation for everybody in my family. The opportunity cost of the mortgage payment, not the dollar cost, but the opportunity cost of the mortgage payment is the benefit I would have gained with my family of going on a vacation. So, real quick summary and review of those two topics. Let's move on to the main topic for tonight, which is the production possibilities curve, sometimes called the production possibilities frontier. You'll notice here, excuse me, the blue line represents the production possibilities curve. Excuse the squiggly nature of it, I had to draw it by hand to show the bowed nature of the curve. So you have on the y-axis here, quantity of product A produced and quantity of product B produced. Along this line are the various points of production. Let's get a little bit more into that. First of all, you notice that unlike the prior slide, where I didn't have labels, in this slide I have labels. Again, just a reminder, you have to label them all the time. Keep in mind the production possibilities curve model reduces an economy down to two goods produced. In this case, either product A or product B. Any point along this line represents the maximum combined output of the two goods given a set amount of resources in an economy. So, for example, if this economy produces 8 units of product A, it can only produce 5 units of product B. That is the maximum that it can produce. It can produce anywhere along this line, and it will represent an efficient amount of production. Efficient meaning resources are fully employed. So all of the resources of that economy are employed in the production of product A or product B. That's what we call efficient. So X, excuse me, X is just as efficient as Y, even though there are different amounts of each being produced. Now there are two additional points here you can see out here and here. First, point L is a representation of an inefficient point of production. Not all of the resources in the economy are being fully utilized here or fully employed. Point K, on the other hand, is one that actually isn't possible because there aren't enough resources to produce that much of A and that much of B. So this is simply a point that isn't possible to be produced. Let's look at what happens when we change the amount of production from X to Y. So the amount that's produced in A and the amount that's produced in B. So movement from X to Y requires that we give up some of the production of A. You'll see the movement here from 8 to 4 in order to gain additional output of B. Simply stated, we had to give up resources here in order to employ them in the production of 11 units of Y. Said another way, the opportunity cost of 6 more of product B, so going from 5 to 11, the opportunity cost is 4 units of product A. Remember, opportunity cost is what you give up to get something else. Now, we've talked about production along this line and the fact that any combination thereof is an efficient use of the given resources or technology in an economy. What happens if the amount of technology, or the state of technology, chip gets faster, new kind of construction equipment is invented? What happens if those technology or resources increase? Find new minerals, things like that. Well, what happens is the entire curve, the entire production possibilities curve shifts out. And in this case, you can see here that Unlike prior, where K was not possible, it's now possible because additional resources or technology have made that happen. Quick review of two different kinds of production possibilities curves. The production possibility curve we will see most often has a bowed nature to it. And you'll see here, because the slope is changing, you'll notice that the opportunity cost changes depending on where you are along this line. So at X, we give up 1 of product A to produce 5 of product B. You'll notice as the curve bows out, and you can tell here the slope. So if I were to draw a tangent, it would be right here versus right here. And don't worry about angles of tangency. Don't worry about it. I can't even say it. None of that will be on the test. You'll see here that in order to get 6 more here, 6 more of B, we have to give up 4 of A. So you'll notice that the opportunity cost is increasing. Now, compare that to the straight line opportunity cost curve. At point X, we give up 3 of A, right here, it's from 10 to 7. We give up 3 in order to produce 4 of B. Because it's a straight line, which means a constant slope, if we go to Y, we give up 3 more. We give 3 more, 7 to 4, in order to get 4 more of B. 4 more of B. So something important to remember is that when we have a when we have a straight line production possibilities curve, the slope of the line, in this case 3/4, is equal to the opportunity cost of the item measured on the horizontal axis. So in this case, B. So every B costs us 3/4 of A. Pretty straightforward, good explanations of this in the book. As a quick reminder, or just a quick recap in terms of calculating opportunity cost, here's a good example that I found in a website called flatknowledge.com. How many skis to get 1 more snowboard? Well, pair of skis along this axis, pairs of skis, and snowboards per month. So how many skis to get 1 more snowboard? Well, in order for us to go from 50 to 51 snowboards, the opportunity cost of doing that, again, the item on the horizontal axis, is, in this case, 2 pairs of skis. Again, the opportunity cost of 1 more snowboard per month is 2 pairs of skis. And that's it for tonight for calculating opportunity cost and exploring the production possibilities curve. Have a great evening.